The experiment I'm just going to show you, or the demonstration I'm just going to show you, is the methane rocket, and or sometimes called the Pringles tube rocket. And the idea here is to demonstrate a couple of things. One is to demonstrate combustion, and two, it's to demonstrate the explosive range of a gas. So what I have here is inside the tube we have some methane, and I filled that from the normal lab supply that you'd have for a Bunsen burner. Now it must be methane that you have, not propane or butane. You need methane because it's lighter than air, and you'll see why when I work through the demonstration. So it must be methane, not propane, not butane. Very important with that. And the idea here is that I've pre-filled this with some methane. I have a Pringles tube here with, if you can see it, a hole in the bottom of the tin, a hole in the plastic lid of the tube, and without the parafilm and without the sellotape on each side of it, okay, I had just a rubber hose, and I blew through from the tap 10 seconds worth of methane, just let it blow through, and then I sealed it with some sellotape on either end. Okay. Now when I've done this before, you can fill a tube with methane the night before if you want, or before a class. Or, generally if you fill it with methane, seal it with sellotape on each end, and have the cap just sealed with a little bit of parafilm. It'll hold for 24 hours. Thereabouts. It should hold fine. Generally, when I'm doing this, I'll fill 2 or 3 of them just in case one of them happens to leak out. So we've a tube full of methane here basically, and that's the general gist of it. Okay, and what I intend to do is to take the parafilm off. Very important to take the parafilm off, and then tear away the sellotape. When I apply the sellotape, I fold a little bit of it back on itself so that it acts like a tab, so that your hands don't stick to it. Okay, so that it's easy to pull off the sellotape on the bottom, pull off the sellotape on the top, and then just light it. Put it on the tripod with the plastic lid, parafilm removed, put it down on the tripod and light it. Okay, and when you light it, what you'll see is because methane is lighter than air, and as I said, it's important that it's methane because it is lighter than air, it will rise and it'll light. You get a yellow flame, typical of a candle or a Bunsen burner that's burning inefficiently. So you'll have inefficient combustion first. You'll be burning away methane in oxygen, giving you carbon dioxide and water. The air is coming in the bottom and replacing whatever methane has been removed. Okay, and as the combustion continues, you're going to get a better mix of methane and air and oxygen. So the flame changes from a yellow flame, inefficient burning, the yellow being the sort of incandescent soot particles, to the bluer flame, which is much more efficient combustion, where you have radicals and more complete combustion, more prompt combustion, and you get the bluer flame. Excuse me. Now, what's happening in this experiment is certainly you have combustion in progress, and air is being drawn in through the bottom hole of the tube, and it's mixing with whatever methane is left. Now, there's a property of gases and vapors which relates to their explosivity, and each gas or vapor will have a lower explosion limit, LEL, and an upper explosion limit, UEL. Yeah? And in the case of methane, if you have anything between 5 and 15% volume and air of methane in air, it'll explode. If you've greater than 15% methane in the air, it just burns, and you'll see it just burning. If you've less than 5% methane in air, it'll just burn inefficiently. So here you have too much fuel, and here you don't have enough fuel for an explosion. Yeah? So this is the sweet spot for methane. Between 5 and 15% volume and air, you get an explosion. And we'll start with 100% methane and 0% air. Yeah? And the idea being that as you burn it, oxygen, air is going in the bottom, and you're getting less and less methane. So you start with 100% methane in here. As it's burning and burning and burning, you go from 100 down to 90, down to 80, 70, 60. Ultimately, you'll hit 20%, 19, 18, 17, 16. Once you hit 15%, it explodes. And it won't explode until that, it'll just burn. And once it explodes, you get the rocket effect. So the Pringles tube shoots up in the air. Yeah. And it's a demonstration of the fact that a gas or a vapor will burn, but not necessarily explode until you hit the sweet spot, which in the case of methane is between 5 and 15%. I mean, the likes of hydrogen, it's between 4 and 74, 75%. So it's a much, much broader window, which makes hydrogen all the more dangerous in terms of its explosive properties. But I mean, you don't discount methane. I mean, at some point you are going to hit the sweet spot and it will explode on you, as you will see. And you get a nice little effect where it shoots up in the air, and a nice little bit of a bang as well with it. So that's the experiment. And I generally have a small little scissors or Swiss Army knife scissors with me. It just makes it neater for cutting off the parafilm, and without sort of interfering with the lid too much. I've been told that you can fill it promptly and sellotape it without the parafilm if you're going to a class directly, and it should keep the seal. But I usually put a bit of parafilm on it. It just adds a little bit of a reassurance that it won't leak out. And as I said, it will last with sellotape and parafilm. It'll hold the gas in there for overnight certainly. Now I'll take the bottom piece of sellotape off with the tab that I've made. Okay, now the methane won't fall out the bottom because it's lighter than air. So as long as I hold it like this, nothing happens. As soon as and the important thing is, be sure to put the plastic lid on the tripod. Don't light the plastic the other way around, or the whole thing catches fire. Yeah, and then I'll take the plastic off the top and light it promptly. Okay, so light it here. Okay, and there you can see the pronounced lovely golden yellow flame, inefficient combustion, where you have incandescence of soot particles, carbon particles. Okay, and the flame gets smaller and smaller as the combustion proceeds. Air is being drawn in the bottom, through the hole in the bottom, through the plastic lid, and you can see the flame beginning to become less visible. It's becoming richer and bluer and more efficient, hotter, more efficient combustion. You're getting this proper reaction now. Earlier we were generating carbon in the yellow soot. Now we're getting the proper combustion. The flame, it might be no harm to do this experiment in a darkened room or with the blinds down. You'll still be able to see the blue flame. I can see it here. It may not show up in the camera, but you can see it just at my fingertip here. And once it goes into the body of the tube, air is coming in all the while as the methane is coming out and burning. So we're maybe at 30% methane, 25, 26% methane, 20% methane. I can just see about the tip blue, and then it explodes. So it was around the 15% mark, and you get the explosion, and there's no burning, there's no charring. It's perfectly safe, and there's a little bit of anticipation, I suppose, with the kids as well, as they see the flame sort of dropping and dropping and dropping, and you can be counting down the percentages as you go along. And if you get it right, it'll pop just as you say, 15%, which it didn't happen there, but it was close enough. And I suppose the final points with it really, I mean, from a safety point of view, it's perfectly harmless really. Just the important things to note. I mean, be sure to take the parafilm off if you're using it, and certainly don't light it with the plastic lid, because the plastic lid will burn. Lid down, and then when it explodes, it just pops up, and just be ready to catch it. And if you really want to go for it, use hydrogen, or if you really want to go for it, use hydrogen and put the Pringles in it, but just put a tray around it. But you get a much bigger bang, and the metal here will bulge as well. Yeah. So that's it. Thank you.